Okay, this is math 2. We're going to do 41 through 44 on this one. Okay, first one should go pretty quickly. Describe each circle by stating the center and the radius. Complete the square to rewrite the equation part B in graphing form. So the first one should be really quickly to state the radius. So in the center. So your center is going to be at 2 comma negative 3. And the radius is going to be at what number? What is this? 5? Yep. Okay, 5 squared is 25. So there you go. So your circle is going to be at 2 comma negative 3. So 2 comma negative 3. And it has a radius of 5. So it's going to go out in 5 up 5 in all 4 directions. Up, down, side, side. And then when you draw your circle, there it is. It's going to have a radius of 5. Okay, the next one says complete the square to rewrite the equation. So the first 2 are x's, the second 2 are y's, and then there's a minus 6. Okay, so let's do the x's first. So we have x squared plus 2, so it means 1x, 1x. We have 1 and 1. And then, so this is basically going to be a 1. The purple ones, there's a y squared, there's a 3y, a 3y, so y, 3, 3, so that's going to be a 9. Okay, so we want 10, and we want them to be positive, obviously. So, what number do we add to negative 6 so we can get a positive 10 out as a result? So, if you do negative 6 plus 4, obviously that's negative 2. That's not a positive 10 as a result. So let's see, negative 6 plus 16. Okay, there you go. There's a 10. So we need to add 16 to both sides. Okay, so that means we have, let's see, x plus 1 squared plus y plus 3 squared, and is equal to whatever we added on the right side, in this case 16. So our center is going to be at negative 1 and negative 3 with a radius of 4, because 16 squared, 4 squared is going to give us 16. So that's going to look like, let's see, negative 1, negative 3, so it's going to be down here somewhere. And then our radius is going to be 4, so we're going to go 4 out one direction, 4 up, 4 around. So our radius is 4, and our center is at negative 1 and negative 3. Okay, 42. I'm only going to do the first one. You can do the second one yourself. So first thing I'm going to do is I'm going to write what's actually happening here. So number 1, where x is being divided by 3, and then the second thing it's doing, we're subtracting 2. So the inverse is going to be the inverse of what we did last. So when we subtracted by 2, that means we're going to add 2. And then number 2, we're going to multiply by 3. Now, there's a reason I want to do this one, because this one's a little tricky. The second one's supposed to be a little easier. So let's see, we're going to divide by 3. So when I write this up, it's going to say, okay, well, f inverse of x is going to be adding 2, so x plus 2. And then we're going to multiply by 3. But the tricky part is, it's not 3 times the x. That's not what's happening here. The whole quantity is being multiplied by 3. So it's really 3x plus 6 if you want to simplify it out. Okay? And then part B, it's kind of the same approach. Multiplying, see, we're going to multiply by 1/2. And then the second thing we're doing is add 5. So then the first thing we're going to do is divide. No, I lied. Subtract by 5. And the second thing is divide by 1/2. Okay, well, that's going to be a little weird if you divide by 1/2. But it should be fine. So x minus 5, right? And then divided by 1/2. Well, that does indeed look different than what you're used to. So dividing by 1/2 is technically like multiplying by 2. If you're not sure why that is the case, I'm going to have, obviously, dividing by a half is multiplying by 2. So you could try it. 10 divided by a half, you could try it yourself. 10 divided by a half, if you take a calculator and say, okay, 10 divided by a half. Well, a half is 0.5. That's 20, right? So 10 times 2 is 20. So dividing by a half is the same as multiplying by 2. Everything gets multiplied by 2. So technically, this is like saying, oh, well, I'm just going to multiply everything by 2. So this is your inverse function from this part right there. Okay, that was 42, 43. Bacteria on Bailey's Petri dish are doubling in area every 20 minutes. Okay, there's your key word. There's your area. The area of the dish covered by bacteria was initially 1 centimeter square, then 2 centimeters square, then 4 centimeters square, then 8 centimeters square. The science teacher asked Bailey's team to predict the area that will be covered by the bacteria after 2 hours. So, every doubling in area every 20 minutes. Oh boy. Okay, I'm writing a thing out for this because, what do we have? The time, right? Time, and then how much? Or the area covered. So at time 0, we don't know. Oh, 1 centimeter was the initial. Oh, okay. 1 centimeter squared. After 20 minutes, it was 2 centimeters squared. After 40 minutes, it was 4 centimeters squared. After 60 minutes, it was 8 centimeters squared. So this can go on for a little while. After 120 minutes, wow, did I just, no, 20 is 80. So yeah, 120 minutes. After 80 minutes. I'm just going to do 80 minutes. After 100 minutes. After 120 minutes. Yeah, that's what I was missing. I'm like, what just happened? 120 minutes is 2 hours, right? Yeah. Okay, this is the 2 hours that we need to stop. So 8 centimeters would be 8 would be centimeters. 32 centimeters squared, and then we have 64 centimeters squared. So how much is there after 2 hours? Well, technically 64 centimeters squared. The only question is, what's the whole point of this? Bailey writes 1 times 2 to the 6th. Cameron writes 1, and this writes this. Okay, well, my advice is to grab a calculator and punch those out and figure out which one of them is actually give you 64 centimeters. So does 1 times 2 to the 6th give you 64? Does 1 times 2 to the 1 over 20th times 120 give you 64? Or does this give you 64? I guess you could work that out. Now Bailey's team has to determine the area that would have been covered by bacteria 10 minutes before they started the experiment. Write 2 different expressions that represent the situation and then determine the answer. Are you kidding me? All right, well, what do we have? Well, 20 minutes ago would have been at 1.5. So negative 20 minutes is the best way to say it. Would have been half of 1, so at 0.5 centimeters squared. So then at 10 minutes ago is pretty much in between 0.5 and 1, which is 0.75 centimeters squared. And then the book wants you to use, yeah, what function? I don't know which one do they want. That's not helpful. It was supposed to be about 0.75 because that's half. Well, anyways, it's around 0.7, I guess, they say. Okay, so 44. You can look online for it's a very long explanation. I'm going to go through it right now. 44. The graph below represents two different quadratic functions. There's this one and this one, I guess. Which function has a smaller minimum value? Explain how you know. Well, the vertex here is at what? 0 and 5, 6, 7, 8, 9. 0, 9 is the vertex. Okay, and then this one is at 0 and negative 3. I would say this one, but I could be wrong. Okay, well, I know, I guess you could plot this, if that works. At negative 2, it's at 7. At negative 1, it's at 0. At 0, it's at negative 3. At 1, it's at negative 2. And then at 2, it's at 3. So, well, obviously that's not to scale, but I don't know, kind of makes its way like this. So this one definitely has a smaller minimum value. The first one anyways. Explain how you know. All the values are smaller. Well, pretty much all of them are smaller than 0, 9. So it doesn't matter which one you pick. They're all smaller. Determine the roots of g of x squared plus 9. User resorts to write the expression of x squared plus 9 as a product. Oh, they just want us to find the roots. Well, okay, so this one is the one that we're doing. Obviously, it doesn't have any x-intercepts. So when we solve this, we should have some i's as a result. So we have x squared plus 9 equals 0. Okay, so this is going to go fast. We don't have an x term in here, so we can just solve this like we normally do. Minus 9 on both sides, so x squared equals negative 9. And then if you take the square root of both sides, we have x is equal to plus or minus the square root of negative 9. So that's going to be equal to x is equal to plus or minus 3i. So that means x is equal to 3i and x is equal to negative 3i. All right, user results to write the expression x squared plus 9 as a product. Oh boy, really? Oh, we just did that one in the previous video. Okay, that was like x squared plus 25. Okay, this should be easy to do then. So we have x plus 3i and x minus 3i. Done. Ooh, this was good. Okay. All right, so there it is. X squared plus 9 as a product is x plus 3i, x minus 3i. And you can actually verify because when you set them equal to 0 and solve, you get those, and those were the answers that we got. Okay, stop here. Do the next one on the next video.